Students, since we don't have much time, so I decided to make some videos to solve exercise 8C. So let's see question number 4. It's page 12 of chapter 8. Algal population on the surface on the pond grows by 10% every day. The area it covers can be modeled by the equation y. So y represents area, where t is measured in days. At 9 a.m. on Tuesday, it covered 10 meters squared. So we can consider Tuesday as initial value. So t equals 0 and then y equals 10. From here, you can find the value of k as 10. Then on Friday, from Tuesday to Friday, Tuesday and Wednesday, Thursday, Friday, 3 days out. 3 days after. So it means t equals 3. So you can calculate the value of y as 10 times 1.1 to the power of 3. I'm not going to calculate it. So just two factors that could be taken into account to make the model more realistic. Okay. So it's like on the pond, the area is going to be covered by algal population more and more, right? Always you need to consider of the environmental restriction. The first one is food. By the population is growing, obviously the leftover food is not enough at some point, right? So that food will affect the model. Secondly, you need to consider the area of pond is not infinite. So it's a finite area. The more area is covered by algal population, at some point, the remaining area is very small, so it will affect the growth rate of the algal population, right? So remaining area. You need to consider these two facts. Let's go to question number 5. The mass of a piece of plutonium after t seconds is given by, so it's a decay. This is negative number, so it is decreasing. Sketch the graph of m against t. Okay, we don't know the value of k, right? In this case, just consider k as 1, the easiest one, right? Then by using your calculator, you can draw a graph. It's gonna be past this 0.1, but actually it's not 0.1. When t equals 0, and then the initial value is gonna be k, so change it as k. Just when you use your calculator to draw a graph, just consider k as 1. Then you can draw a graph as y equals e to the power of negative 0.01x. Then the graph is going to look like this. How long will it take to reach 25% of its original mass? So what is the original mass? Initial value, right? The mass when t equals 0, which is k. Then 25 of its original mass means 0.25 k. Then we need to find t. Do you understand? Okay. Then the mass is 0.25 k equals k times e to the power of negative 0.01 k. You can cancel k each side, right? Then by using the logarithm definition, or you can put ln each side, right? Then ln 0.25 equals, you can move it to the front, negative 0.01 t ln e. Since the value of ln e is 1, so the value of t is ln 0.25 divided by negative 0.01. By using your calculator, you can find this value. Question number 6, population size, okay, is defined in this way. T days. Initially 450, so N0 is 450. and increasing at a rate of 90 per hour. 90 per hour. It's not 90 per day, it's 90 per hour. And then it's a bit tricky. We need to calculate A. So N equals 450 times e to the power of AT. And then the rate means gradient. Gradient is 90 per hour when t equals 0 because it's the initial value. It's related to initial value. So the gradient of this one is 450 times 8 times e to the power of AT. So when t equals 0, this value is going to be 1. So the gradient is 450 times 8. The thing is, if you calculate this one as 90, then A is going to be 9 over 45, but it doesn't make sense because 90 per hour, but T measures in days. So you need to convert it as in days. Since 1 day is 24 hours, so that 90 times 24 is the increasing rate per day. Do you understand? Therefore, instead of 90, you should input 90 times 24 as the value. So A equals 90 times 24 over 450 divided by 90. Then the value of A is 4.8. Again, the increasing the rate is given 90 per hour, 90 per hour. But we need to convert it per day because this model is measured time in days, right? So you need to multiply by 24 to counter a day. Okay, how long will the population size take to reach 2,000? So 2,000 equals 450 times e to the power of 4.8, since the value of A is 4.8 t. Then divided by 450, so 2,000 divided by 450 equals e to the power of 4.8 t. Put ln to each side, move this to the front, and then this value is 1, therefore 4.8 t equals ln 2,000 over 450. Therefore, the value of t equals ln 2,000 over 450 divided by 4.8. I'm not going to calculate it. You should calculate it by yourself by using your calculator. Okay. Question number 7. Radioactive substance. Okay, decay. Rate of decay, the gradient, is numerically equal to 40% of the number of atoms remaining at that time. Okay, so the gradient is numerically equal to 40% of the number of atoms at the time. Initially, there were 500 atoms, so it's an initial value. Write an equation to model the number of atoms n at times t days. So firstly, since they say the rate of decay is numerically equal to the number of atoms remaining, it means that exponential growth or decay. Please bring back your memory. Okay. So if the rate of change is proportional to quantity itself, the remaining population, rate of change is proportional to the quantity itself, remaining population, then we call this one as exponential function, or we can model it by using exponential one. So the basic one is n equals n0 e to the power of kt. As initial value n0. Let's go back to the question. So since rate of change is numerically equal to 40% means the rate of decay equals 40%, the multiplier is 0.4 times the number of atoms remaining. They say we should use n. So this is proportional to the number remaining, right? Number of population remaining. So it means that exponential decay, so we can write it as n equals n0 e to the power of kt. And since it's decay, we can assume that k as negative number. Since 500 atom is initial value, so you can put 500 here. Then the rate of decay is numerically equal to 40% of the number of atoms remaining at the time. So the gradient, let's find the gradient. The gradient of this one is 500 times k times e to the power of kt. And then 500 times e to the power of kt is actually n, right? So the gradient equals k times n. And then it's 40% of the remaining atoms, okay, equals 0.4. The thing is, since it's a decay, so the rate of decay means the negative, it should be negative value, right? Negative value. It should be negative value, therefore k should be negative 0.4. Does it make sense? So n equals 500 times e to the power of negative 0.4. T is the answer. Okay, again, rate of decay, okay, negative value is numerically, so rate of decay is negative, equal to 40%, 0.4 of number of atoms, which is denoted by n here. Do you understand? Rate of decay is gradient. So firstly, you need to figure out this is about exponential decay because the rate of change is proportional to the remaining population as it is. So we can model this one as n equals n0 initial value e to the power of kt, where k is negative number since it's decay. Then since 500 is the initial value, so you can put 500 here, then n equals 500 e to the power of kt. Let's find gradient of this one. Gradient is 500 times k times e to the power of kt. Since they say the gradient is negative 0.4 times n, this is negative 0.4 times n. Please bring back your memory. 500 times e to the power of kt is n here, right? So k times n equals negative 0.4 times n. Therefore, the value of k is negative 0.4. Therefore, n equals 500 e to the power of negative 0.4. T is the model of this situation. I hope you understand. I'm sorry I murmur or I stutter in the middle. Let's move to the next question. The value of a new car. Okay, 1 year later, the value has decreased to, okay. Assuming the value continues to decrease by the same percentage every year. Write the model to the price of the car in the form of V equals P times e to the power of kt. Whoa, this question is really difficult. Actually, this question is related to question number 2. Do you remember the definition of E? So E equals 1 plus 1 over n to the power of n as n goes to infinity. Do you remember that? And then if the annual interest is P%, if we give interest once a year, and then after 1 year, it's gonna be 1 plus P over N, and then the initial investment money. And if we gave P twice a year, and then each time we are gonna put P over 2% of interest. And in this case, after 1 year, it's gonna be C1 plus P over 2n to the power of 2. One time a year, once a year, twice a year, and 100 times per year, it's gonna be C1 plus P over 100n to the power of n after a year, right? After a year. Okay. I feel this question is super difficult. I hope you can understand. I'm going to make another video to explain this question because it takes a lot of time and many steps are needed. And that it's 10:30, so I need to go down to have my phone time. I'm gonna make another video for this question.